Okay, hi everyone. Can you all hear me?
Yep.
Okay, excellent. So my name is Kirsten. I'm a postdoctoral fellow at Dartmouth College, and I work with Dr. Brad Duchesne, who I believe some of you know from his time at University College London and from faithblind.org. I'm his stand-in for today. And I'm going to talk about our work with developmental prosopagnosia in children, which is something that's pretty new, I think. But first, I just wanted to let you know we did manage to track down the wallet cards. If some of you are asking about if you can print out a wallet card, you can go to faithblind.org/links and you can download this card here. There seems to be one for the US and one for the UK. I don't know if they just put U's in the letters. I don't know what the difference is, but there you go. Okay. So today I'm going to talk about what developmental prosopagnosia is, and the definition is actually kind of important when we're talking about childhood prosopagnosia. What do we know about childhood DP? What current research is being done? And what can be done for a child with DP today? Because the research is just in its infancy. Okay, so our definition of developmental prosopagnosia is that it's a neurodevelopmental condition characterized by severe face recognition problems that result from a failure to develop the necessary visual mechanisms for normal face processing. The reason that this is important is because it means that it's probably present from an early age. And I think this sort of came to light for us because we had adults telling us, I remember when I was a child and I had difficulty recognizing faces. It's just that we've never really gotten around to investigating this in children yet, until just recently. So the prevalence of developmental prosopagnosia is estimated to be between 2 and 3%, and that's from self-report studies and behavioral studies that have been conducted in a number of countries. So there's a lot of converging evidence that about 2% of the population is walking around with developmental prosopagnosia. Now there are a few suspected causes, and we need to do a little bit more investigation, but I bet some of you are wondering, how can this come about? How is it possible that you could be born with face blindness? And the 3 causes I'm going to discuss briefly are experience, neurological factors, and genetics. So there's some evidence in the literature that children who are deprived of pattern visual input in the first few months of life show face processing deficits. So these are typically children with dense cataracts. Even if those cataracts are removed at a very early age, even 1 month of age, those children can show face processing deficits throughout life. And this is even if object processing is returned to normal. Okay, so there seems to be some long-lasting effects, even if visual input is deprived at a very early age, even if it's restored at an early age, face processing doesn't seem to be very forgiving. Children raised in institutionalized settings and children who are extremely shy show some face processing deficits. So children who are raised in institutionalized settings have a lot of cognitive deficits in addition to face processing deficits. And we're not too sure exactly what the contributing factor is here, but it's possible that they're not getting the regular exposure to faces, or maybe that close exposure to faces with a number of caregivers that they really need to develop their face processing system. And with children who are extremely shy, it's unclear whether these children had face processing deficits and became shy, or whether because they were shy and didn't look at faces very much, they sort of lost their ability to process faces. And these are just some sort of extreme examples of things that can lead to face blindness, and experience is just one factor that could contribute to it. So it's not that you had some unusual event in your upbringing that caused you to be face blind. These are just some factors, because there are also neurological factors that could come into play. So there are 4 areas in the brain that are critical to face perception, and these are some areas that we would probably want to look at if we were suspecting that someone was having difficulties recognizing faces. And of course people have done that, and they found that in developmental prosopagnosia, individuals may have abnormally developed areas. They may be smaller in size, they may be not quite as functionally active, there may be difficulties with the connections between them. All of these results have also been countered with other results that show that the brain looks totally normal. So this is kind of early stage research, but just showing that there may be some sort of neurological factors that are contributing to an inability to recognize faces, even without damage to the brain. And of course, when we're talking about changes in the brain. We're unsure whether those brain areas were like that from the beginning and that caused the inability to recognize faces, or whether it's the inability to recognize faces that then led to changes in the brain, or for the brain to not develop normally. A third factor is genetics, and we know that developmental prosopagnosia tends to run in families, because a lot of prosopagnosics have said to us, you know, I've spoken with my father and he said he's had the same problems his whole life. We also know from twin studies that there's a high correlation between face processing skills of identical twins, and that correlation is twice the correlation that you see in fraternal twins. Now, identical twins share twice as many genes as fraternal twins. So what I'm saying here is if an identical twin is very good at recognizing faces, chances are their identical twin will be very good. But that relationship does not necessarily hold for fraternal twins, so that shows that there is a genetic link. However, it is unlikely that all cases can be explained by genetic factors, because we do talk to prosopagnosics who say, I don't know anyone in my family who has this. This is just me. I don't know where this came from. So it seems like those three factors, any of them can play a role, and it's definitely likely that in some cases they actually interact. So what do we know about childhood DP? I'm going to say very little. There's only 10 reported cases in the literature. And the youngest case that we've had reported to us from faceblind.org was 3 years old. But of course, it's very difficult to assess in a 3-year-old whether they actually have face recognition problems. But when you talk to parents, they quite often say, you know, my child's now at 8 or 9, but I remember when they were a year and a half that they weren't quite looking at me normally, or they weren't distinguishing me from strangers. So it seems like this is something that can be recognized at an early age, but it's very hard to actually pinpoint whether a child has prosopagnosia. But what we do know from speaking with parents and from the few cases reported in the literature, that there does seem to be the same heterogeneity in developmental prosopagnosia in children that you see in adults. So while some children have navigational problems in addition to their face recognition problems, others do not. Some report having other disorders like dyslexia, others do not. There are 2 reports on training children to recognize familiar faces. And I know Sarah Bate already talked a little bit about training studies, but because these were in children, I'll just quickly talk about them. These children actually had the same training strategy that Sarah spoke about. They were trained to attend to try to remember 5 features of a face of familiar people. And they did show improvements in their ability to recognize those faces. It's a little bit unclear about how far that generalized to their ability to recognize new faces. So while it really helped them in their daily life to recognize mom and dad and those faces that they were trained with, it's unclear whether they were then able to extend those strategies to recognizing new faces. But that's a huge gain for these kids, because at least they can develop some contacts with familiar people who they need to be able to identify. There's also one unpublished training study by DeGutis et al. At Harvard. Joe DeGutis was kind enough to share this information because, unfortunately, one thing in science is that if something doesn't work out the way you planned, sometimes it can be very difficult to publish that. But this is very important information for us about a study that didn't work, because it gives us information that we can use to then try to find something that will work. So what Joe and his colleagues tried to do is to train a 13-year-old named Timmy to recognize his mom compared to not mom. So it wasn't try to remember all these faces or try to learn to recognize everyone. It was just distinguish your mom from women who are not your mom. And after 10 months of training, Timmy showed no gains at all. So again, it was very nice of Joe to share the information about the study with us, because we were able to learn about what exactly happened with Timmy, but also to figure out what strategies Joe used and maybe modify those to try to get something to work in the future. So some red flags that people can look for in children, because children often don't recognize that they have a problem because they assume everyone else has the same difficulty recognizing faces. But red flags would be social isolation and anxiety, failure to recognize someone if they change their appearance, like their hairstyle, or if they're encountered out of context, and reliance on other cues for recognition, such as hairstyle, voice, the way someone walks, their clothing. So these are other things that people have been mentioning today, and it's amazing that these kids can pick these things up so early in life. So some of the parents have told me that their kids are better at recognizing someone from behind than they are because they recognize the way they walk and their hairstyle and their clothes. These children also have little interest in TV shows, as we've talked about. TV shows, particularly those portraying human characters, but we have to watch their cartoons because they can figure out who people are. So I've also got in here some aha moments that parents have sent to us. So this mom said, we first realized that our daughter had some issues when she was very young, around the age of 18 months. She never seemed fearful of strangers as typical children are. She underreacted to me in my presence. So this early sense that this little girl didn't have a different behavior for strangers and familiar people. And this mom said, I drive a white SUV, which is a very common color car here. She would attempt to get in the wrong white car after school in the pickup line. She didn't recognize the person sitting in the car, but she did recognize the car. And this just highlights the danger that there is out there for children who don't know who a stranger is and they don't know who's familiar. So they can just get in the wrong car and be in a very serious situation. And then I thought this was a great example. I'm just going to have to read it from down here. I was looking at some photos of a soccer party for my son's team. The kids were not wearing the soccer uniforms, just regular clothes. He looked at the photo and he asked, which one is me? He studied the photo for about a minute and a half and then picked himself out. He said he looked at everyone's clothing to see if he could figure out which clothing was his. And he said he had to look at the clothing because no one in the picture seemed to have hair like him. That's when I realized that the kids had been running around and so his hair had been soaked with sweat and looked darker than normal. So basically this child just went through all the processes that he uses to recognize people, and this was a red flag for the mom, and he said, wow, that is not normal. He can't pick himself out of a picture. He would normally use hair, but in this instance it wasn't a reliable cue, so he switched on to clothing. Again, it also shows how clever these kids are, that they can pick out these strategies very early. So what are some consequences for kids? They're going to be limited in the activities that they can partake in and the courses that they choose. They're not going to choose something like drama, where they can't figure out who anyone is. They're often unable to start and or maintain social relationships, and they have concerns about getting lost or being separated from their parents or teachers. So a lot of these kids report having serious anxiety about being separated from mom and dad because they're worried they're never going to be able to find them again. There's extreme difficulty with transition to middle school. So when you think of it, the early years, kids are paired up with one teacher, one class, and they stay in that class all day. All of a sudden, middle school, you have to change from classroom to classroom and figure out where you need to go. So this can be very difficult, and a lot of parents report to us that they've decided to homeschool their kids because it's just too stressful to put them into school every day. You can have anxiety in the classroom, which may have widespread effects on learning. And in childhood, there's often a tendency to misdiagnose or confuse face blindness with autism or Asperger's, because these children do withdraw, and they might not look at faces the way that regular people do. They might be studying them, they're not making eye contact, they might avoid the faces altogether. And you can imagine if a child is given a diagnosis of autism, that they're going to receive very different treatment than a child who is diagnosed with face blindness. So that's something important that we need to hone in on really early. So what is the current research that we're doing to try to help these kids? The important thing right now is to develop diagnostic tools, but we also have some theoretical issues that we'd like to address. Kids will help us address whether there are different types of prosopagnosia, and we've learned from adults there probably are. They'll help us understand the neural underpinnings and the developmental trajectory of developmental prosopagnosia. So how does that change from a child into adulthood? And it's going to help us with the development of training strategies. So I'll talk briefly about these in turn. Our main goal right now is to develop diagnostic tools, because right now in America anyway, there's no official diagnosis of prosopagnosia. It's not in the Diagnostic and Statistical Manual, which means that parents seeking resources from school are often told that the school's hands are tied. They can't help someone without an official letter or diagnosis from a doctor. So part of the reason that they don't have any diagnoses is because there aren't any really well-designed tests for kids out there. They need to be valid and reliable, and the tests that are out there right now often have hair in them or extra facial cues like glasses. So some of these kids take the tests and they ace them because they're so used to looking for these other cues, and then they're not properly diagnosed as having prosopagnosia. So these are the tests that we're currently developing: face memory tests, face perception tests. non-visual or non-face visual processing tests, so that's object recognition tests, and other assessments like low-level vision and autism tests are very important for assessing children. I'll just briefly show you some of the tests that we're working on. For those of you who are familiar with the Cambridge-based memory task, this might look familiar, except the face might look a little younger. So we have developed the same test where you need to memorize faces and pick them out from a choice of 3. In this case, we use children's faces, and we made the test at an appropriate difficulty level for kids. In part 2, you're given the 6 faces that you need to memorize in part 1. You need to review them, and then you pick any of those faces out from choice of 3. And then we add visual noise or blurriness to the faces in part 3. And children 7 to 9 years old memorize 4 faces, and the older children memorize 6 faces. So this will tell us if the children are having problems remembering faces in particular. We also have a test we call the old new test. So you memorize 10 faces, and then you pick out the faces you've seen from a choice of 2. So it's a little easier for the younger kids. This is another measure of face memory. But we also want to know if children are able to even match faces. So maybe this is where their problem actually lies, is they can't even figure out if 2 faces are the same or different. So this is our face perception test. Your job is to pick the face from the choice of 3 that matches the one at the top of the screen. They all look very similar. But
none of them do they? Tricky.
Yeah. They all look very similar, but with a bit of time, the regular kids are able to pick out the best match for the one at the top, whereas children with face recognition problems seem to perform a chance. We have a motion recognition task, so your job here is to pick out the face from the bottom 3 that has the same emotional expression as the one at the top. And so you don't have to figure out who it is, you just have to figure out the emotional expression. It was such fun making this test with these kids and asking them to pose these facial expressions. We've got a face detection task, so you need to find the face as fast as you can. And we've got children's faces and adult faces in there. I don't know if anyone's found that one in the top right-hand corner. We've got object tasks that are matched to our face tasks. So the flowers task at the top is just like the old new faces task. You need to memorize 10 flowers and pick out the one you've seen before at the choice of 2. And then we've got our Cambridge bicycle memory task, where you need to remember 6 bicycles and pick out those bicycles from a choice of 3. And so what these tests are designed to do is be matched in difficulty to the face tests, and that will tell us if someone has a selective problem with faces compared to objects. And we tried to pick stimuli that would be fun for the kids to keep their interest. So I run these, quite a few of these tests with some kids in America, and I've been testing kids during my time in the UK. These are some of the kids I worked with in America. So the kids' initials are listed here with their ages in brackets, and then the tests are up here. In brackets, those numbers represent chance level performance, so if they were just guessing. So what you can see here is that these kids were kind of close to chance, especially OP at the bottom there, 37.5%, chance level 33% for the Cambridge face memory test. And the same for perception and for the old new faces. And then when we look at the old new flowers, we see that their scores tend to jump up. So if you look at MF up here, she's got very poor scores for the face tasks, but she actually outdid her peers with the object tasks. So this is all an exception to RK, who's a great example of someone who showed generalized processing deficits. He did not show an improvement when we gave him object tasks. So these are the types of things we're looking at. And I know that's a lot of numbers, so I've got a graph here of MF's scores. Percent accuracy on the y-axis, and then the different tests are along the bottom there on the x-axis. MF scores are in yellow, and the dotted line represents chance for each of those tests. So the take-home message here is that she is struggling with the face tests, which are the first 3, and then you can see her performance jumps up when we give her an object recognition test. So this is her scores compared to other 12-year-olds. Okay. So using those tests, what we can do is try to figure out if there are different types of developmental prosopagnosia in childhood. And our goal is to learn whether there are different dissociations of different types of face processing abilities. So for example, are there some kids who are really good with face memory, but poor with face perception, or vice versa? Are there some kids who are really poor with face recognition, but they're fine with expression recognition? Or are there some kids who are actually poor at both? Or gender discrimination, or age discrimination, and I heard some people talk about ethnicity. So these are all things we want to test. This would provide information about the neural mechanisms of developmental prosopagnosia and the developmental trajectory of developmental prosopagnosia. So what I mean by that is that we have basic areas in the brain that process faces, and we have some idea what these do and how they communicate with each other. And so if we figure out what a behavioral deficit looks like, we can infer which area of the brain is going to be what we want to look at in those individuals. In terms of the developmental trajectory of developmental prosopagnosia, we can ask questions like whether the same types of developmental prosopagnosia that we see in adulthood also exist in childhood. Do they exist in the same proportions in adults and children? And is the severity the same in adulthood and childhood? And so you might think that someone who has developmental prosopagnosia at an early age would just have the same type of developmental prosopagnosia at the same severity. But you could also imagine that it could get worse over time, or that their face processing systems might improve over time. So that would affect the proportions that we're seeing, and possibly even the types of prosopagnosia we're seeing. So by studying kids longitudinally, but also in groups and comparing them to adults, we can learn about how prosopagnosia changes over time, or if it does at all. Okay, so another goal for our research is to develop training strategies, and right now there are no effective training strategies for children. Some programs that are designed for children with autism hold promise for children with developmental prosopagnosia. So some of our collaborators at the University of Minnesota found that a child known as B showed major gains in face recognition after training with a program called FaceSay that was designed to help children with autism to recognize faces. The problem with a program like FaceSay is that it might not be appropriate for training kids with developmental prosopagnosia because it does have extra facial cues like hair and freckles on the faces. So we have had some parents who have gone and gotten these programs on their own and then come back to us and said, well, my child did fine on level 10 right away because she was just using the hair to decipher the task. So while these programs are clever and they're very good for children with autism, I think they need to be adapted for children with developmental prosopagnosia. And of course, we're trying to plan new training strategies, and I know Sarah May is working on adapting her adult strategies for kids as well. Okay, so given that we don't have anything to offer you today from our research, what can be done in the meantime until we do have some developments? So I'd just like to point out this book, Understanding Facial Recognition Difficulties in Children by Nancy Mindick. I've heard that this is very helpful for parents because it just talks about some strategies that you can use at school and at home to help your child learn to recognize people, even if it's using clothing and hair and not necessarily facial features. So accommodations can be made. It's always important to keep in mind that what is effective is going to vary from child to child. And also, not all children are aware that they have a problem, so sometimes you need to be sensitive to how you bring that up to them. And not all children want or need help. So we have been in contact with parents who are really insisting that their child should come in for studies and learn about their condition, and the child says, I'm totally fine, I've got lots of friends, doesn't bother me. So these are all things that need to be kept in mind when trying to accommodate these children. But at school, you can do simple things like have the school send home photos of key staff members so that the child can try to learn them before school starts. You can have staff wear name tags or distinctive pins. You can have the class make name plates for their desks to help the child identify who's who. Ask staff to point to people when referring to them. These are probably all strategies you guys are all saying, of course. This is not new to me. A buddy system would be helpful for kids. And then with a bit of thought, maybe disclosure of the difficulties to the classmates and the parents of the classmates. And we've heard of kids who have said that they're actually targeted by bullies because the bullies know they won't get in trouble because they can't be identified by the victim. So that's always something that needs to be thought of beforehand, whether you want to go and tell everyone at the school what's going on or not. At home, you can have family members wear distinctive clothing or pins, obviously not in the home, but if you're going out anywhere. Some parents have told us that they've put little markers on their cars to help the kids recognize the cars. And of course, you can tell family and friends so that they can approach the child in a different way. And as we discussed in our training strategies that we reviewed, the child might be able to memorize some key features of family and friends, and that might be able to help them. That was effective with those 2 children who were reported in the literature. And what about a service dog? Well, we're working with a young girl named Maddie, and she just got her service dog Dutch, and she's very excited about having Dutch because Dutch is going to help her figure out who is stranger and who is familiar, because Dutch can learn faces and he can learn to sniff out who's friendly. The other thing that Dutch can do for her is Dutch can provide a social buffer. So when someone meets a little girl with a dog, one of the first things they do is they say, "Oh, what a cute little dog," and they look at the dog. That gives Maddie time to assess who is this, that she can listen to their voice, and it also allows them to see that she's a friendly person and she's not standoffish. It makes her more comfortable and really provides that buffer in that social interaction. So I'm really anxious to see how this works out for Maddie. I think she's taking Dutch home in the next couple weeks. So in summary, we don't know much about developmental prosopagnosia in childhood, but we're working on it. Kids with developmental prosopagnosia have a special set of concerns like stranger danger and special difficulties at school that need to be taken into consideration. Our current research is focused on diagnosis, because in order to study this in kids, we have to diagnose them first. Understanding the developmental trajectory of developmental prosopagnosia and trying to develop treatment strategies for the kids. There are a number of strategies that can be used to help a child, but the important thing is that they should not feel alone, because there are lots of them out there, and they just need to know that, that there's support out there with people like you. So if anyone needs any more information about prosopagnosia in children, rather than putting up the really long URLs, I just put up some information that you can Google. So our group is Googleable by Faceblind Dartmouth College. There's Faceblind 60 Minutes, will take you to the video of Timmy. And there's also a Proso Kids Google group through the Jonas Lab at the University of Minnesota for any parents of prosopagnosics who want some support. Or you can always email me with some. I think if we're going to start, I'll get to you just a second.
It's quite surprising the prevalence is 2% worldwide. Is that the tail of Down syndrome distribution abilities, or is there really a hump at the low ability end?
Okay, so there's, I think, a bit of controversy in literature as to whether it's a normal distribution, these people are at the bottom of the tail, or whether there actually is a separate population that experiences developmental prosopagnosia. I'd say the overwhelming support from our research is that there's a normal distribution. So these kids are representing just that tail end of people who are struggling with face recognition. Yes?
Do you think the time will come when all children should be screened on admission to primary school?
Great question. So you just asked if children will be screened eventually for this when they enter school. And that's my goal, ultimately. In fact, I would like that to happen sometime soon. I think our CFMT would be a good first pass for that. And we're networking with schools right now to try to figure out if there's some way that we could integrate that into the school system. Yes?
I was just wondering, that's been aired on television, yeah? That lad's now known for being basically, and just recently I've been hearing all the time about children being abducted or things happening, and I'm just curious, my immediate thoughts are that it's great to be able to help, but are we not really causing other problems that we see?
Good question. So what's going to happen? Parents are very hesitant to identify their children that 14 and 6 feet tall, and he's a big guy, and he walks around like he owns the place. So in that particular case, Timmy's not too worried about his safety. But it is an important concern when we talk about having children disclose things to their friends, their school, or even participating in something bigger like being on national television. Yes?
I'm interested that just looking around and talking to people, it seems that in this room there's a high level of education and mostly I think middle class people. So is that because we're the sort of people who come to these meetings? Or could it be that because we have a high level of education and therefore general intelligence, perhaps we have managed to compensate more than some other people? So the question is, are the people that we know now the people who are well adapted because they've managed to get on in life despite this? And are we missing, do you think, a group of people who perhaps went through childhood, withdrew because they couldn't compensate and are now?
Yeah, it's a great question. That, especially in America, people are contacting us, or people who are saying, my child is struggling so much, and we had to pull him out of school because he's so anxious around people. And we're worried that we're actually testing a population of children who are massively affected by this and have serious social consequences and anxiety and other comorbidities that are going on with this. Sometimes we even wonder if we're getting kids who are purely face blind because they might have some other issues that their parents can't quite identify, so they start Googling everything. They come across face blindness and they say, well, that might fit, and they contact us. So while I agree with you that the adults that we work with are often the ones who have sort of figured out what's going on and they've adjusted very well, quite often with the kids we get the opposite, that we get parents who are noticing that their children are struggling, and that's why they contact us. Yes?
You alluded to ethnicity. When you're devising the screening tests, do you match the ethnicity of the child's environment with the trial faces? Does it matter?
Yeah, good question. So do we match the ethnicity to the child? So there are well-known other race effects, even with regular people. So you're going to have trouble recognizing people of another race. And so what we try to do is just give them the best opportunity they have by matching their race. And we started with Caucasian faces because Dartmouth College is in a very Caucasian environment, and that's where we're taking our photos. But if we do have a child who grew up surrounded by another ethnicity, we always do try to take that into account and take the results sort of with a grain of salt and say, oh, what if we did test them with another test that had another race in it?
Anybody got any more questions? Okay, so we move on. So